traditionally, biomedical research, when you do an experiment, it tries to reduce the heterogeneity in the data to make sure that when the conclusions are made, there is no known confounding factor. Instead, what we have been focusing on is using a lot of data that's very heterogeneous, some might call it dirty data, and use this a large amount of dirty data to identify a signal for a disease that is robust across multiple independent data sets and is clinically useful. And we've shown that this approach works in broad number of data sets, broad number of diseases, including autoimmune diseases, organ transplant, infectious diseases, cancers, for identifying diagnostic and prognostic biomarkers, new drug targets, and drug repurposing. So we applied our dirty data approach to identify a diagnostic signature for tuberculosis. 1/3 of the world is infected with latent tuberculosis, and about 180, 190 million people worldwide have active disease. But even in 21st century, it's very difficult to diagnose active TB. And what we were able to show is that using almost 2,600 blood samples from 11 different countries in 14 independent cohorts, we found that there is a 3-gene signature that distinguishes who has active TB from who has latent TB, who has other diseases that look like TB, and who are completely healthy with a very high accuracy. And now what we are working on showing is that it also allows us to predict who's going to have active TB much earlier than clinical diagnosis. It correlates with treatment response, and that it can be used as a screening tool for identifying the patients who may have active TB and should be treated as soon as possible.